Hello everyone, I am Cemre. Today I'm excited to guide you through our presentation, which revolves around the progress in our psychosis simulation project. First of all, I'm going to talk about our project shortly. Our primary mission is clear, is to define the requirements for the psychosis attack simulation. This simulation is not just a technological endeavor, it's an immersive experience designed to help users better understanding and navigate psychosis attacks, where Unity's game engine and Arduino technology converge to create a realistic tactical journey. Users actively engage with unfolding scenarios guided by educational resources, gaining insights into causes and appropriate responses. Our ultimate goal is to empower users with knowledge and effective coping strategies for potential psychotic episodes. Here is our purpose and scope, which I'm talking about before. And now I'm going to talk about our progress so far. We've made significant strides in crafting a realistic and immersive simulation using cutting-edge technologies. Leveraging the Unity game engine and Arduino technology, we aim to simulate not only the audio and visual aspects, but also the physical experiences of individuals undergoing psychotic attacks. And our simulation places users in the driver's seat, allowing them to actively manage a character and observe the emotional changes and reactions within the simulation. And here's a quick overview of the key components we'll be exploring. We'll start by discussing the improvements we've made to our software requirement specifications, and next we'll delve into the project plan, and this comprehensive blueprint outlines the journey ahead, including milestones, timelines, and strategic steps. And we'll share our vision for the project's evolution, demonstrating our dedication to truthful planning. And after that, software architecture, we'll explore the design decisions and that shape the functionality and user experience of our psychosis simulation. And to prove a visual insight into our project structure, we've developed various architectural views and diagrams. These include collaboration diagrams, ER diagrams, deployment diagrams, and user interface diagrams. And as we progress, our commitment is to refine, adapt, and improve based on user feedback, technological advancements, and insights gained during development. And thank you for listening to me. Now I'm going to give my speech to my friend.
Hello everyone, I am Utku Eyüp from Computer Engineering Department. Now I'm going to explain overall description part of our simulation. Let's start with system interfaces. First of all, the system or the simulation will work on Windows 10 operating system, and communication of Arduino and Unity is provided by system input-output port library in the Unity. User interfaces part. The game will show the buttons and possible options to the user. These options in the main menu, and also main menu containing resume, settings, and exit button. The game will show players choices after the game and give feedback about their choices in the game, during the game. And also users can set the sound settings during or before the game. For the hardware interfaces, vibration motor and temperature pad will be used by Arduino, and its communication with Unity is based with USB for data exchange. Software and communication interfaces. The game will develop in Unity engine, as I mentioned before, and in here, communication is provided by C++ script in the Arduino library. Memory constraints, it is required to at least 16 GB of RAM, and Unity's built-in memory management shall be utilized to handle databases that handle memory. Let's talk about assumptions. If the users met or exceed the requirements, the game will satisfactorily work. And dependencies, the game will work on computers with Windows 10 operating system or more versions of the Windows. There is no need to internet in order to access the game. For the requirement subsets, we will apply the survey to the users at the beginning, whether they are suitable to play this game or not. Based on the scientific research we will produce and we did so far, we will determine effects and ask the experts to scale the how realistic experience we offer. For the operations, our simulations operations, the game will start and close with start and exit buttons. When the player choose start button, the simulation will start, and when the player choose exit button, it will close. Specific game events occur. Vibration motor and temperature pad will be triggered when the specific game events occur. Each option will affect the game's flow, and each option will be stored, as I mentioned before. Product functions. The game will be first-person perspective. User can interact with specified in-game objects. Visual, sound, and whisper effects will be reflected to the user by Arduino and Unity also. Constraints. The game codes will be written as C# in Microsoft Visual Studio for Unity versions after 2020. For the Arduino Uno will be used, and as a programming language, C++ will be used and written in Arduino IDE. Now I am giving to my turn to Fahrettin.
Hello, this is Fahrettin. I will speak about specific requirements right now. Other page. About platform and language requirements. The game will be in English and it will run on Windows 10 operating system. Other page. User interface requirements. The main menu should have start settings and exit buttons. And when the game starts, the game will be paused when the user press exit button on the keyboard, and the game should provide feedback to player regarding the choice they make. And the game will one ending, but it will change with the choice made by player, and the game should enable in-game sound settings from the settings menu. Exactly, I said that. Other page. Player experience requirements. Players will hear whispers in specific situations to explain the analysis. And the thermal pad connect to Arduino provides temperature feedback in predefined situations. And we have vibration motor connects and pulse sensor connects. We have pulse sensor connect to Arduino 2 to collect pulse data used for heartbeat, sound, rhythm in the game. And with that, the game will blur the player's vision with predefined stations, and the game includes visual shaking for the player in predefined stations too. Other page. Design requirements. I will talk about this type of design requirements in this slide. Other page. Auditory hallucinations. The game will automatically simulate auditory hallucinations, which allowing users to experience unreal sound and voice. And it will connect with the storyline about protagonist physics and contributing. Other page. Visual distributions and unreal colors. We will use visual distortions and unreal colors in our game. Visual wait. Uh, in this time in this type of situations, user or the player will see some visual differences and under colors in the game. Other page. Negative consequence of change. It will change with the game of the choose the players make. We will change the map according to the our storyline and the player's choice. Other page. Immersive audio design. We thought that we have to add stereo audio design in our games because of the explaining the illnesses. And with that, we will use 3D audio technologies in our games. Other side. Gradual associations. The onset of physical episode will occur gradually, allowing players to experience the build-up sensation and unease. And with that, this gradual escalation serves an educational elements and to players understand the announced progression of mental health challenges. And so the game will explain the illnesses to people who don't have these illnesses or who have these illnesses and afraid of it. Other page. Interactive responses. The game will be interactive from the player's responses, like touching an object or touching an character, and with that, player can change the dynamics of the game, and will make choice. Other page. Visual and auditory consistency. Visual and auditory elements of the psychotic episode will assign with the overall aesthetic and theme of the game, ensuring a consistent and cohesive experience. And the game will utilize 3D environmental models. As I expected, the game will be first person perspective too. And with that, we thought that if we combine them, the game will use educational tools and like people who have this disease should act like that, or when they act like that, it will change some things in their life too. Other slide. Post-episode impacts. The game shall acknowledge and reflect the physiological aftermath of physiologic episode and supplementary gameplay. This is about we will pop up some scenes of the players' past scenes to explain the situations which players having in the health problem which them caused about post-traumatic illnesses. Other page. Other page. Okay, my friend will continue with this parts. Ceyhun will continue.
Hi everyone. I am Ceyhun Kurt. My department is computer engineering. Today I'm going to talk about our project's non-functional requirements, supplementary requirements, software methodology, and use case diagram and system architecture. Let's start with non-functional requirements. Non-functional requirements divide two parameters, performance requirements and supplementary requirements. Performance requirements are our game shall run minimum 16 GB of RAM and NVIDIA GeForce RTX 2060 graphics cards minimum, and minimum Intel i7 19th generation 2.6 GHz processor, and we need 25 5 gigabytes of storage, and finally, the game shall provide 60 FPS. Supplementary requirements are storage of physical permission, establishing. You can stay this page. Supplementary requirements are storage of physical permission, establishing tremor-proof environments for the secure storage of permission documents, preparation of permission documents, creating details forms for participants before and after the simulation, capturing information about their profession and awareness of physiological impact, preparation of the simulation environment, configuring an inviting and noise-free room and for the simulation, furnishing comfortable seating arrangement for participants. Participants in the simulation must fall within the age range of 18 to 40. Let's check with the our software methodology. We can thank you. Our software methodology, we utilized the waterfall methodology in our project, incorporating the use of a Gantt chart during the planning phase. Start and finish dates were determined and outlined. Let's continue with system architecture. The simulation system is structured into three main components: Unity, Arduino, and Firebase. Unity provides the primary game functions to user, while Arduino facilitates hardware operation based on the game data and sends data back to the game in response to hardware input. Firebase is employed to store the data transmitted from the game in the database. Now, let's check with the use case diagram. This is our use case diagram. You can see it. We start with main menu, and if user click play, open the survey. After that, game will start. In a game, user can interact game objects, and then can control character and can access pause menu. Otherwise, at the beginning, user can access the settings and can control the audio, or user can exit the game, as you see. Now, my friend Kaan will continue with use case documents.
I am Kaan from software engineering department. I will talk about the class diagram, collaboration diagram, deployment diagram, and our progress in the project and test distribution. And last one, budget criteria. First of all, our project is class diagram like this. Generally speaking, thanks to our DB manager class, we will be able to exchange information with Firebase and keep the data of the surveys we conduct to user in a database. Our UI manager class will be used to manage the user interfaces in the project from a single class. Since we will be making audio settings through the UI manager class has relationship with our class audio manager, which provides this. Since we need to interact with the objects and the person we talk in our game, we have the player interaction class that provide this. In order to create the dialogues that will occur after these interactions, the dialogue manager class is associated with the play interaction class. Our player movement class allows our characters to move, and the related player command move camera classes are used to move the camera depending on this movement. We can continue. When we look at our collaboration diagrams, we can see the communication between the systems and the databases after the user fills out the form and starts the simulation. Such communication was necessary because we wanted to store the surveys in the database. We can continue. In the deployment diagram, we see these layers because we created a simulation by combining three different layers. These layers are Arduino for hardware and physical responses, Unity for providing game functions, and Firebase for collecting the data we obtained from the survey. We can continue. If we look at our Gantt chart, we can see what we have done in the project so far. We decided to project idea in the first weeks, and then we did research and decided what we could use to develop this idea. After determining this, we created our requirements document and started the game development process. We have completed most of the necessary systems and designs. We can continue. Throughout this process, we distributed the task as you can see in the table, while we shared the subjects such as project management, Arduino development, database integration, user interface design, and sound design among the people. We decided to share the remaining ones. We can continue. When it comes to budget part, as you can see, we determined the cost of things such as software, hardware, and labor. We use a result of our research. We can continue. In our user interface, we designed the interfaces that are the main requirements of our game. These designs are the main menu, stop menu, interaction with objects, and appearance of dialogues, respectively. We can continue. Now we will talk about the codes of our systems. First of all, this code is used to measure the player's heart rhythm from the pulse sensor and proportion the heart sound in the game to this rhythm. We can connect Arduino and Unity with this codes. When we look at the Arduino part, first of all, the pulse sensor library is required to use the sensor, so we could include it. The pin to which the sensor is attached determines the threshold values for heart rhythm. Then the serial connection between Arduino and Unity started with the port number. Using this serial connection, heart rhythm data is sent to Unity in the loop section. When we look at the Unity code, the system IO ports library is included so that it can use the serial connection. This game object is purchased publicly so that we can affect the heart rhythm sound. The serial connection that we will use later is created and initialized. The incoming data is read from the serial connection with the readline function, and the settings of the sound object are changed accordingly. Now Cemre will continue with continue.
I'm going to explain our player interaction code and interactable interface. Interface interactable declares two methods, interact and get description. Any class that implements this interface must provide implementations for these methods. And this script allows the player to interact with objects in the game world. It uses raycasting from the camera's center to detect interactable objects within a specified distance. If an object is detected and implements the interactable interface, it shows an interaction prompt and triggers the interaction when the player presses the E key. The UI for interaction is displayed or hidden based on whether an interactable object is in range. The script is also designed to work with a dialogue manager to ensure that interactions are not triggered while the player is in a dialogue. Secondly, I'm going to explain our dialogue manager script. It handles the display of dialogue player choices and the progression of the narrative. In the start method, references to the text mesh pro UI components are obtained and initializations are performed. The start dialog method is called to initiate a dialogue. It sets up the environment, initializes the story instance, and displays the initial dialogue. In the update method, the script checks for player input to advance the dialogue. If the story can continue, it displays the next sentence. If there are choices, it shows them. Advanced dialogue advances the dialogue by fetching the next sentence from the ink story and displaying it. And the finished dialogue marks the end of the dialogue, hides the dialogue box, and resets the cursor state. The type sentence coroutine is responsible for gradually typing out each character of the dialogue for a more dynamic display. Parse tags are extracts and parses tags associated with the current dialogue, and show choices displays choices when the player needs to make decision, and set decision sets the choice selected by the player, and lastly, advance from decision advances the story after a decision is made. Now my friend Ceyhun will continue.
Hello again. Player movement and camera code. Player movement script allows the player to move in the direction they are facing using the Unity physics engine. The movement is based on the user input, and the force applied to rigid body is proportional to the input values and the specified movement speed. We use fixed update method is used for physics-related calculations. And camera code script allows the player to control the camera by responding to mouse input. The X and U axis rotation are updated based on mouse movements and are configured within limits. If a dialog is not in progress, mouse input is utilized for controlling the camera movement. The settings for cursor locate state and cursor visible ensure that the mouse cursor is confined within the screen and remains invisible. This allows the player to interact with the game using the mouse while the cursor stays fixed in the middle of the game screen and remains hidden. Thanks for listening us. Have a good night.